Hello and welcome back everyone. As we have learned about the conductor, semiconductor and insulators, let's learn that what is valence band and conduction and what I'm bragging about these things. Okay, so for the assumption of the thing, let's understand it with an analogy. Like this is our earth. Okay, our earth is not red, it's blue, but let's consider it's our earth. It's my drawing, right? My right. You have to give me that first, right? Okay, so this is the range in which you can have your satellite going on. You can have multiple satellites. I just made one, and there are actually so many satellites. Okay, now what with that? So this is the range where for the satellite, and you can call this range as your conduction range. And this range at the surface is known as valence range. So what I am using this analogy for? I'm using this analogy for the band gap concept and to tell you that why the conduction band is so important. So to understand it more clearly, let's learn this like that. The last electron of the sodium Na, which is having the number 11, atomic number 11, and A, atomic number 11 means 11 electrons are there also. So we are considering these 11 electrons here. So 11 electrons. So in the last one there is just one electron as you write the configuration of it. So it will going to come up like this. 11 number, last one, 1 is the last electron. So let me make it a little more realistic. This is our nucleus and this is the first layer, this is the second layer, and this is the last electron that we are focusing upon and talking about, because when you are standing outside the first thing that you see is this electron and not the inside ones. Okay, now what with that, it will not going to conduct heat or electricity in this range, so this range is not going to work. To get a useful or meaningful work, you have to bring this electron, get excited and come to this level, this point. So this is what we call the conduction band, and this is obviously the valence band, which is a part of the dominating part of the nucleus is till this point. So what is point? Is the nucleus not working? No, nucleus is working. The force of attraction is there. Otherwise, the electron will have escaped, like here. It has escaped, but it did not escaped means it stayed here. So now let's understand this analogy that is going to get clear from now. Satellites do not get out or do not fall down. It can move freely in this orbit with minimum quantity of the energy that we require. So this is the work that we can get from this place. And as you have probably seen that the gravity is almost 0 meter per second square in the satellites, like in the International Space Station. If you have not seen that, you can watch that. There are so many several videos of NASA and all the such places who work and flows on the satellites and all that places. So this is this range. So the gravity is not effective, but obviously gravity is there, otherwise the satellite has been escaped. So this is the concept here. To get useful or meaningful electricity, we need electron to get excited and move in this orbit. When it moves in this orbit, so we can get more quantity of electricity because the electron acts like it's free from the bondage of the nucleus attraction. So this is all about the semiconductors that we have learned and how to make the things happen by using the conductor. And this gap is so large in the insulator that it's not possible, and this gap is comparatively a little bit lacking in the semiconductors that we can help it for. So the next one we are going to explore more things. Take care, God bless.